may come across 10 terabytes of table. It's not a database, it's a table. So table size maybe 10 terabytes or 5 terabytes. So very usual, very often you'll find the table size with 1 terabyte. It's not a database, it's a table. So
Yeah.
So the reason is that Teradata is basically a data warehouse. It's not a OLTP application. It's completely for historical data warehouse, right?
Okay.
So you may have, the table may have definitely 5 years or 10 years of data, or maybe in the future you may need to keep the data so for 10 years or more than that. If you are into a banking domain or financial services, or maybe an insurance basically. So these kind of domains, they need to store the data for 20 years or 30 years, right? So definitely there will be a table growth. So how you perform, whenever you try to read the table, definitely there will be a performance defect, because you are going to fetch the data from a terabytes of table. It's not a single table. And you will find billions of records in that table. And you need to pinpoint one particular account. Suppose you are into a banking domain or maybe an insurance. So let's say I have a LIC. So I need to go with that whenever there is a need of identifying what is the premium and how many years it is going for that and all those details if I want. So I need to pinpoint one particular account out of billions of records. So that is really a big challenge, right? So for that we have a different architecture in Teradata, both in physically, the way the Teradata hardware is designed, and the way the LDM, the logical data model, is designed. So Teradata comes up with both software and hardware. The hardware also designed by Teradata itself, and of course the software.
Okay.
So this is the basic architecture. It includes both software and hardware components. The hardware, that what we can say in simple way, the CPU, whatever that we have for desktop systems, you will find a CPU, right? So the CPU that we have, the unit that we call it as node in Teradata.
Okay.
So that particular node has different components. Physically there are binaries, there are of course CPU, RAM, different kind of drivers to connect to the system, and there are different gateways you will find, and of course different it's a server, so it may not be a single system, there will be a multiple systems, they work together, and we can use it as a single system. So multiple nodes connected into a network, and they work as a single unit, single system. So that is MPP, we call it as MPP, multiple systems, or maybe a single system. If your business is very in a starting stage and you have very less data and you have very less number of users that connect to the system, then maybe your business requirement is may need one system, not require more than those that systems. So in that case, you will go with one AMP, what is Binet, what is PDE. So these are all software components that are installed in your node, one of the nodes. Not one of the nodes, all the nodes that we have in the system. So we need to discuss all these, because whenever there is a, suppose let's say there is a database restart. So the restart may happen because of AMP software, failure in the AMP. So you need to understand what is AMP, why it failed in AMP, and how you can get it back. It may be an offline AMP, so how you can get it back to online. So that is not primary support. I mean, primarily the DBA has to work, but you need to understand, you need to identify, because there is a third level, the support that comes from Teradata, the vendor. So whenever they need those kind of details, you need to in a position to give those details, right?
Okay.
So that you must know. Maybe sometimes system is quite busy and you don't know that. End users, definitely they complain that we are not able to connect, so there is a database down. But internal system is quite busy, so because of that they are not getting resources to connect to the system. So that is the reason they are experiencing like a database down or database hang situation. But as a DBA, we should not say that system is down, right? Because system is up and running, everybody is able to connect, but there is a lag. The response that they are getting, that is throughput or response time is less. So in why it is less? So performance degradation, how it happened? So is it because of parsing engine, more number of sessions that connected to the parsing engine? Is it an uneven distribution of sessions controlling, or maybe a AMP is skewed, or maybe there is a problem from the PD or some other software? So that analysis you have to do as a DBA, and you need to understand, and what you have to recommend in the future, how you can ignore them, avoid.
Okay.
So these kind of things, if you should know, then definitely you must know all these things. What is PD, what is AMP? So we discuss all this. And yeah, so when there is a database, data warehouse, definitely you must have a recovery or protection of data, right? So there will be a database backup definitely on weekly basis or monthly basis, or sometimes for some users, some customers, they may go with hourly, daily basis. The data will be taken back. So how the backup is done, and at the same time how you can protect your system. Like if there is any problem from the software perspective, definitely you can understand. But if there is a hardware failure, DBA, not only DBA, any human, they cannot get it done immediately, right? You cannot guess this particular hardware component is going to fail, so that database may experience a restart, database bounce will happen, so that we cannot say that. So in such cases, if there is a failure of the one of the hardware components, something like AMP is down, then how end users, there should not be any impact to the business, there should not be any outages. So system should keep going, everybody can able to connect to the system, they can run the queries, they can get the data. Maybe one of the components is down, but still they can get the 100% data. So how that can be achieved? So there are different concepts, like cliques we have, AMP clustering we have. So with this hardware level, how you can give the protection to the data. So if there is any hardware failure, immediately standby will come up. So how this a table or view is locked, so that you can, some other users cannot read while the table is going into a DML operation. Something like you are inserting the data, I'm trying to read the data. So definitely there will be a blocking. There should be a blocking, because you are updating the table, you're doing a DML operation, I'm trying to read the data. So it's not accurate. Maybe whatever the record I'm trying to read, that particular record is going to going for an update.
Okay.
So that's not, I cannot trust that particular data, right? It's not reliable. So in such cases, the table should be locked. If you are doing a read operation and I'm doing a write operation, definitely there should be a blocking. And before that, since my session started first, so I have to lock my table so that no one can read that particular table. So how the locking mechanism is defined, and journals. So let's say, suppose there is a transaction is going on, and in the middle there was some failure, maybe because of database restart or hardware failures, or maybe there is a error from one of the columns, or maybe one of the query statement in the transaction. So when there is a failure, definitely whatever the transactions DML operation that happened in between these transactions, that should be rolled back, right? Otherwise, suppose let's say you are inserting the data, millions of records into a table. So after 50% completion, there was a restart. So what about the existing 50%, the inserted 50% records? We don't know how many records are inserted. I can approximately say 50% of the records. But what are the records that are inserted? I don't know. If you are doing a traditional simple insert statement, maybe you can guess. But if you are doing an operation, something like you are reading the data from a flat file and you are writing the data into the table, you cannot say that because it's a blocks of data. It's not a normal traditional whatever the insert statement we have. We are not doing that. So in such cases, you cannot say that these records are inserted and you cannot delete them. So in that case, we must have external thing that can either do a rollback or maybe roll forward. Or maybe there is a database failure. So in such case, it's not a user fault, it's a database perspective, right? So system has to handle few of the things similar to this. So there will be three types of journals we have. If there is a AMP failure, then record journal we have. If there is any, if there is no failure, but as a best practice, before you update or delete whatever the DML operation you are going to perform, you are taking the table backup.
Okay.
That is just temporary. So for that we have transfer journal, and if the user know that there may be a chance of failure, transaction failure, so he already know that. So he wants to handle himself whatever the failure that happens for this particular transaction that I have to roll back or roll forward. In that case, he can define his own journal. So that will that goes with permanent journal. So there are three levels of journals that we discuss, and of course virtual disk arrays, click, AMP clustering, and virtual disk arrays. These are our hardware level data protection, how that nodes can be connected to each other so that one node is down, other can come up and the standby will come up, or maybe sometimes standby may not be there. So other system, other node can share that system, whatever the node down, its data will be shared by other systems and they can give 100% availability. So,
okay.
So that is our goal. Whatever the hardware failure happened, there should not be any impact to the business. Of course, we cannot avoid some circumstances where system must be down. So how it happens? So our aim is at least 70% of the business should be up.
Okay.
So how you can achieve that? So those things we can discuss here. And this is for your convenience. Like we don't have any software. If you go with SQL Server or Oracle, you can install the software in your local machine and you can connect to the database and you can do whatever the testing you do. But Teradata, they don't give any software. That basically database software is not available. It's not freeware. So we have a virtual images that is given by Teradata. You can download them. And so that is the complete software. The database is installed on SUSE Linux and it's a virtual image. We can download it and we can play that image as a server. You can use it as a server and you can connect to the database and you can create the tables and all those.
Okay, so I can still put that in my Windows laptop, right?
Yes, you can. The only
Okay.
thing is your laptop should support virtual technology, VT. If that
Okay.
is if you have that, then you can install this one. There is no problem.
Okay. So I have one question here. Like, so you'll be giving me all the necessary softwares, everything in my system. You'll be installing it.
Yes, I can give you the link. I'll give you all the links. You can download. Once you download everything, one session, one day will sit and will install all the things. It hardly takes once
Okay.
you download everything, maybe hardly takes 20 minutes max.
Okay.
So there are different images. You will find 4 GB images, 40 GB images, and 1 terabyte images. So it depends on the requirement. So for us, 40 GB is enough. You can download that,
Okay.
and we can configure that.
Okay. So this 40 GB image, it will have the necessary softwares and what else it has? Just the software alone and the necessary components?
No, it is actually the images. It's an operating system completely installed,
Okay.
and the database DBMS, whatever the Teradata DBMS that is installed, everything is installed in that. So you can use it as a server.
Okay.
So from outside local machine, you need to install the utilities, tools and utilities, the client utilities, through which you can connect. Maybe SQL Assistant, you know that, right?
Yeah, I understood. Yeah, I have it.
Yeah. So to connect to the database, you must have SQL Assistant. So that for that you can download this TTU, installation of TTU. So you can download
Okay.
that software and you can install. But VM image is the software.
The server.
RDBMS. Yes.
I understood. That's a server, right?
Yeah. So in your laptop itself, you will have client server architecture.
Okay.
And these are the different client utilities that we have. Client who can, the end user, how he connects to this database and he can run the queries. So BTEC, this is the command line interface. SQL Assistant, that is a graphical representation. This SQL Assistant is not graphical in the sense most of the MS Word document, whatever the shortcuts and features that we have that are included in SQL Assistant. And this is not only for Teradata. Through SQL Assistant, this particular tool you can connect to even SQL Server as well. So
Okay.
it works on both Teradata.net and ODBC. Whenever there is a ODBC database in your system, you can connect to that system as well.
Okay, so it uses
define,
ODBC.
yes, you just need to define the ODBC DSN.
Okay.
And Teradata Administrator, this is another utility. This is similar to Toad, if you know Toad.
Yeah. Yeah.
So it is almost similar to Toad, but through this you can create a database, you can create users, you can do all administrative tasks like creating a role, profiles, and granting the rights. If you want, you can do that. Graphically you can do, you don't need to write any query, but ideal scenario, the real time, you don't max, hardly we use this administrator tool. The reason is that everywhere you will find the store procedures because they need to track everything. So auditing should be there. So for that, if you go with Teradata Administrator, you may not be in a position to track every transaction. Suppose let's say as an administrator, I deleted one table, I dropped one table. So I should know, I should not do that. So in such case, if anybody wants to track that particular thing in the future, so they may not be in a position to do that. So not 100% access given to DBA, but there will be a procedure who runs store procedure which can be enable you to execute those things, like something delete database or drop database kind of things. If you want to do that, maybe you can do it through a store procedure so that you can track. So there will be a metadata which tells every transaction what is happening from DBA perspective.
Okay.
And there is one more tool, tset. This is hardly we use, but there are many uses. Something like, suppose there is a database restart happened and there will be a dump generated. So that is given to the Teradata, that is vendor. So there will the restart may happen due to one of the queries that is written by a user. So there may be a bug in the software. So what they want is they look for the query and their associated objects so that they can reproduce the same in their local machine, in their lab machines. So we need to get everything. What is the query and what are the underlying objects, views, tables, whatever the functions, UDFs that are defined in that query. Maybe they are using those queries, those UDFs. So everything should be captured, the DDLs and the statistics, everything. If you can export everything and provide it to the Teradata, they'll import the same in their local lab machines and they can reproduce this problem.
Okay.
So that is DBS job. If whenever they want those kind of things, so DBA has to provide all these things. So how to use the tset and how you can get the data, how you can export that data. So that we will discuss here. Arcmain is the utility that is for recovery and backup utility. That is the tool. It's not a tool, it's a utility. It's a command line utility. So based on this, there are many tools, third-party applications you have, and also Teradata have they have some utilities defined based on this. Something like net backup, that is the IBM server where the storage is defined. So something like SAN, storage area network.
Okay.
So
okay.
Net Vault, Net Backup, these are the two servers that are backend servers for backup for Teradata. So whatever the data you take into a tapes, that will be stored on the Net Backups and Net Vaults. But
okay, you mean the Veritas Net Backup?
Yes.
Okay.
So to take the backup and to store the data from the Teradata database, you must have a utility that is Arcmain. So which connects to the database, it takes the backup, it dumps the file. Once the dump is taken, then maybe the dump file, you will move it to NetVault or Net Backup.
Okay.
So this is the heart. So we need to understand how you can archive the table or database. Similarly, if you want to move the table, suppose let's say you have test and production boxes. So you need a table or maybe a group of tables, set of tables. You want to move them from production to test data. So in that case, you can archive those tables on the production box and you can move the copy, you can move the dump file to the test box and you can copy that or restore the tables from the dump to the test box. So you are just moving the data from production to test. So for that you have Arcmain. Arc is stands for A for archive, R is for restore, and C is for copy.
Okay.
So these are the three things that we can achieve from this archive or analyze, recovery, or restore, copy. So these are the three things that we do from Arcmain. So that we discuss. Visual explain, this is to see the plan, explain plan, how the query is performing. It is going to execute, what are the different steps. So visually you can see that. So this is query for query performance tuning, you may use this. But very rare we use this visual explain because we always go with the explain text instead of visual. So we'll discuss
what is the
that.
other one?
Normal explain text. text.
Oh, okay, explain text.
Yeah, this is visually.
Okay.
Visually you can see. So if there is a table, there will be icon to represent the table. If there is a mapping, something like if you are familiar with ER diagrams. So
Yeah.
similar to that, it will display the explain text. Visually it will show. So we very rarely we use this. That is not. It is recommended, but we don't use it because we are familiar with the text. So we go with the text, explain text. So that we
Okay.
discuss anyhow. Database window is the troubleshooting window. So suppose there are different things in the system. So you will find the different types of performance fields. Sometimes you need to change them, or maybe sometimes you need to see the any failures in the disk level. So let's say suppose you are upgrading the system from 13 to 1310 or 1310 to 14 or 14 to 1410, some major version upgrade. So during that time you need to, there are few things that you have to do before the start of the upgrade. So you need to identify any errors or any issues with the disk. So physical disk drives. So you need to run scan disk to scan the disk and to find the failures, any issues from there. So you need to clear them before you go with upgrade. So these are all DBA tasks. You need to run scan disk. You need to run check table, checking the table status. Is it table is sometimes maybe user is loading the table with some data, and it is through a mload process or something. So that the load job got failed, and it is under maybe kind of a the table status is unknown, in the sense you cannot read the data from the table and you cannot write anything into the table. So it is not at all useful because it's a pending operation. So how you can identify that kind of tables? So we need to run check table on that at database level, so that you can identify, okay, these tables are pending operations, these tables do not have valid indexes. So system will scan all the tables and it will generate a report. So based on that you can take the required actions. Suppose if it is a pending operation, you can simply drop the table because it is not at all useful. You cannot read the data, you cannot write into the table. So you can drop the table. So these things, by administrative things, you can do it from database window. For Windows system, we call it as database window, but nowadays you don't find database window because there is no Windows systems. They are all Unix systems. So SUSE Linux basically. So we find console terminals, CNS console terminals. So
what do you call that?
CNS console terminal.
Oh, okay.
It is same. Database window is from Windows perspective, and CNS term is
from the Linux.
Yes. So here even database window is some way you can call it as a GUI. It's not exactly, but you will find some utility there. You will write some commands, type some commands, and submit. But when it comes to CNS term, you don't see anything. It's completely command line. How you do your commands in Unix, the same way you need to type everything in the there itself, and you need to understand.
Okay.
So that we discuss, and this is the basic LDM physical implementation. Tables, different types of tables we have. Set table, we have multi-set, volatile tables, temporary tables. Derived tables is common thing that you will find everywhere. It's just an SQL thing. But set table, set, multi-set, volatile, and global temporary (GTT). So these are the different types of tables that we have in Teradata. Permanent tables. Some of them are temporary tables, and of course views and macros. Macro is a kind of function which won't store the data. It just suppose you use same query, you can define it as a macro. You don't need to write every time the entire query. You are just going to change one particular variable, maybe between this date and this date. So start date and end date. You are just changing those two values in the query every day or maybe a hourly basis. So you can define a macro and you can execute the macro so that you don't need to write same query every time. So those are macros that we discussed. And here the administration starts. So we have different types of databases based on their role, what kind of data they store, and other thing is that in Teradata, both database user, both are databases basically. They both are databases. There is no concept of other than database, like you have schemas and all those. So those are not in Teradata. Whatever we have, whatever you see, that is a database. And if the database has password to connect to the system, then the database is called as a user. If there is no password, you cannot log into the system using the database name, then that becomes a database. So basically database holds the data, that is you can create the tables, whatever the objects you want, and create them in a database. You want to read the data, manipulate that particular tables or data, you need to connect to the system. So for that you need a user. That's it. So a database and a user, both are databases, but user will have a password, database will not. That is only the difference you will find.
So you, so you say every database will have another user database?
Yeah, exactly.
Oh, okay.
Suppose, let's say if there is an application. So for application wise, for entire application, there will be one application user, that is the administrative user. And maybe for that application, you need 4 or 5 databases. So suppose, let's say there will be a table database. So the database holds only the tables. There won't be any other object. You just create it. If you want to create any table in that application, the table must be created in the database, and whatever the view you want to create on top of this particular table, that should go into other database, that is database view. So that particular database will hold only views, and there will be some other business. You may say, some people they call it as security views, some people they call it as transaction views, some people they call it as business views, semantic views. So depending on their requirement, but all these are similar. Suppose let's say business view. What is view? View is always a one-on-one view, right? So there is a table, you create a view. So it's a one-on-one. So all the records, all the columns of the table are displayed through this view. So it's a one-to-one base view. But a view which has a business logic based on some row level security. Maybe if the user name is something like ABC, only that particular user can read the data from this table. So it's a security view.
Okay.
There's a logic defined in that. So a security view or maybe a business view. So to store these, to hold these kind of views, you may create another database. So that is a, you can say security view database or transaction view database, whatever you want to give the name. So there will be 3 or 4 databases this way, which holds tables, views, different views and all those. And to read from this data from this table or database, you need to have a user who can read the data or who can write into the tables. So there will be an application user. Yeah.
So all these users with a different access level will be in the users database.
Yes, exactly.
And
so that is the best practice.
Okay. One more question is, say when you said macros, so how about macros? It will have another separate database?
No, that macro doesn't hold any space. it won't require any permanent space. You can create anywhere, even in a user with 0 permanent space, you can create them.
Okay.
Macros are basically for the our convenience. I don't want to repeat the same. I don't want to write same query every time.
Understood. It's only for so it's only for us. It's not for the application perspective.
You will find even for applications also you will find some macro store procedures, but they go into some one particular database. Usually, if there is a table database, it holds only tables, no other object. If it is a view database, you will find views, macros, any other object other than table.
Okay.
So views, you may create views, store procedures, macros, user-defined functions, UDFs, data types. So all these go into same database, one view database. So we have different databases, and DBC is the super user. Also, you can call it a super database. So DBC, since it has a password, the database becomes a user. So this is the actual super user, and it has some tables, dictionary tables. Suppose let's say I want to know the list of users in the existing system. So there will be a view called as dbc.users. Let's say suppose I want to know all the databases. It may be a database or a user. Then there is a table dbc.dbase. So the dbase, the table will have the tables about records about the databases that you have in the system, complete system. It's not like in SQL Server, or maybe if you go with Oracle, there will be an instance or maybe a schema, and schema is part of the database. But here all the databases are under DBC. All the applications comes under one tree, one umbrella. So that is DBC.
Okay. And the dictionary tables are all our system tables, right?
Exactly. They are all system tables, metadata tables.
Okay.
So we discussed that, and we must know dictionary tables. We should be familiar. At least for DBS, they should know every table.
Okay.
So we discussed all the tables and views. There are some macros also defined in this, and there are also some auditing tables, DBQL tables, that also we discussed.
Okay, so this dictionary table will be in which database?
DBC.
Oh, it's inside DBC. Okay.
And space management, there are 3 types of spaces we have: permanent space, spool space, temporary space. So what is the difference between all these 3? How it works? How you modify the database with permanent space, spool space? What is the difference between these 3 spaces? That is very important. So we discussed this one. And next thing is administration, user administration, in the sense creation of roles, profiles, access mechanism, like access rights, how you grant the access rights, nested roles, nested profiles, account strings. So all this we discuss. All these are while creating a user, what are the considerations? After creating a table, how you can give the access to that particular table to the end user. So roles, rights, profiles, so these things we discuss. And this is the physical implementation. So this is very important for everybody, not only for DBS, even for architects, developers also, they must know these things. So there are, we define table. So while creating a table, you must define a primary index. So based on that only the data will be distributed.
Okay.
So if it is an uneven distribution, you will find the skewness. If there is a skew, uneven distribution, and there is a skew, definitely the data table, whenever you read the data from that particular table, it's an expensive query. it becomes an expensive, because since it's a skewed, one particular amp needs to work more compared to other amps. So CPU, high CPU and high I/O. So while doing the tuning query optimization, so you need to know how primary index, maybe sometimes you need to recommend the user to change the primary index of the table.
So what is exactly skew?
Skew is, it's a big thing, big concept, but I'll give you briefly. Suppose, let's say I have 3 glasses, okay? I need to fill the glasses with some water. I have some jar, okay? I need to pour that water into these 3 glasses. Suppose on the first glass, it's completely full, it's saturated, and second and third glasses, they are all half of, they are not full. So this is the concept. So first three glasses, first glass is completely full, it is you cannot pour anything into that, but second and third, there is some gap, 50% and 30% gap is there. So in this case, these 3 work together. So the full first glass, since it is full comparing to other 2, so this glass we call it as a skew, because it's not evenly distributed.
Okay, the situation which you said is skew.
Yes. So my intention is I need to give this water in an equal distribution among these 3 glasses.
Okay.
But what I did, based on my primary index, the algorithm. So since I have chosen bad PI, maybe you have chosen me, because of that I poured all the water into first glass and few drops into second and third. So first becomes the skew. Entire process becomes a skew one. So whenever you want to read the data from first table, so here these 3 glasses are 3 parts of the table. So first portion is completely full, and while you are reading the data may be from first class, second or third. You don't know. So maybe all the data is on first class only, and second and third may be idle. But they wait until first partition or portion says I'm done with the data, I'm done with my job. Then only second and third gets released. So until then they will be idle, they will be locked. So it's a waste of resource. So this situation is called as skew. It's a big concept. There are different amps involved, AWTs, table sizes, and primary index, how you define the primary index, and different types of primary indexes. It's really very big concept. We'll discuss that.
Okay.
In short, the situation that you have these 3 classes, the filled one, that is a skewed one.
Okay, got it.
And secondary indexes, if you want, you can define to optimize the query. So different types of secondary indexes, primary indexes, hash, join indexes that we discuss. This all comes under physical implementation. Physical implementation in the sense LDM process. How you define the table, how you can, why you need to define primary index, secondary index, join indexes, in which situation, and what are.
So what do you call LDM?
Yeah, logical data modeling.
Okay.
So how you can define all these so that query will perform well. So that is our intention. So how this should come from the architect basically. Basically in real time, architects will define, okay, this is the table, this requires this joins with this particular table. Based on ER diagrams, they define everything. A developer, he should understand the concept, how the data will flow in a table, what is the column that is repeatedly used in a join condition, or maybe how often you read the table, and how often you load the data into the DML operations. How if suppose you have selected one column as a primary index, so that may go every time whenever you update, it may go into an update. That particular column may go for an update. So that should not be a PI in such cases. So developer has to understand, and he has to identify whether this particular column can be a primary index or not. So those things should be understood by architect and developers. And DBS, of course, once everything is done, once they are online and they are into production, you start seeing the degradation, failures. So then you need to dig into the physical level, how the table was created and what is the PI, how is skewness, skew factor. So based on that, you may need to recommend to change the primary index.
Okay.
So all this comes under tuning part, physical query tuning. So to tune that, you must know all these things. So that we discussed. And these are all basic commands. Different types of transactions we have, BT, ET, ANSI, and if you want to schedule a job, BTEC job, how you can create a batch. If it is a ad hoc queries, so you can go with interactive. So show command, explain plan. So visual explain is a utility, but explain plan is a Teradata SQL feature. If you put explain in front of the query, you can see the steps, how system is going to run this particular query, execute this particular query. So that explain plan, collect stats. This is very important. If you don't collect anything on the databases, on the tables, then the plan is not optimized plan. It's a really optimizer will get a bad plan. So how it is and how you can collect the stats and all those, that we discussed. And this is the performance monitoring. As a DBA, you must know viewpoint, because whatever the process sessions running on the system, and you have to monitor them. You need to find if there is any bad query running, maybe a user running the skewed query. So when there is a skew, definitely CPU skewed or IO skewed. So you need to identify that particular such kind of queries, and you need to abort those queries, or maybe you can ask users to tune that query or kind of. So monitoring should be there. So the viewpoint is the PMON. It's not only PMON. There are various things, different things. Even database window that we were discussing, that also part of viewpoint. So you can do it from viewpoint perspective. Even you can run the scan disk check table, but they are not recommended from this application. But you can execute them, you can run them. You don't need to every time. You don't need to connect to the database node and you as a root level, and you don't need to do everything from root. You can do it from viewpoint as well. So that we discussed. And DBQL is the auditing database query language. So this is completely for auditing purpose. So let's say suppose a user complained that his query is running really bad today. Last week the same query, it's a weekly job. Every week it takes 10 minutes to execute, but today it is running for 2 hours, more than 2 hours. So there is a problem. User, since it's a job designed by the user, so he knows end to end what is happening, and is it really takes 2 minutes or 2 hours. So those details he will definitely know. But DBA, as a DBA, you don't know all these things, because it's not designed by DBS. So you need to dig in. Last week how it was, user saying it took 10 minutes to execute. Is it really it took 10 minutes? What is the reason? Today it is running for more than 2 hours. What is the reason? So you need to get some metrics, right? So those metrics, those analysis can be done through DBQL tables. And these DBQL tables are part of DBC, and you can call it as dictionary tables. It's not dictionary, but they are all DBQL tables.
Okay.
These are also system tables. To capture the data into these tables, you need to enable the access mechanism, and you should also define blocking DBQL query to enable. You have to enable that DBQL on the object level or database level or table level or user level or session level.
Okay.
So how you can do that? So beginning and ending of the query language. So that also it is. Until you begin the DBQL, nothing will be captured into this table.
Okay.
So you should enable them. If it is a initial system setup, new to Teradata, and because nowadays most of the customers, they are moving from Sybase or SQL Server or maybe Oracle to Teradata. So Oracle, in the sense, not OLTP, whatever the online analytical they have, so they are moving from there to Teradata. So for them, Teradata is new one. So it's a starting step. So you have to enable the DBQL everything on the system. So how you can do that? Object use count, all these things. You can object use count is, suppose a table, how many times this particular table is accessed, how many times this particular column is accessed. So those things also you can capture. Based on that, you can, okay, this table is never used in the last 6 months. So what is the use of retaining them? And either drop the table or move the table into archive. You take the backup, drop this particular table from production. So you can save some space, right? So troubleshooting.
Yeah.
So these kind of things you can understand, you can analyze from DBQL. And these are the console uses. So database window, whatever the window we have. So through that you can execute all these show logs to see the any archive job is running, and there will be a log placed on the objects. So show logs will show that those logs. Log display, this is universal. All the logs placed on all the objects by all the users that are running currently.
Okay.
Or maybe suppose, let's say you have placed a write log and and it's a ANSI SQL, like it's not auto commit. So you are done with your work, whatever the load operation, you're done, but you forgot to release the log. So log will be placed forever. You disconnect it, but since it's an ANSI, it's not auto commit. So definitely until you say commit, it will be there. But you disconnected your session, so you cannot do anything on that. So the log will be there forever. So the only option is you need to restart the system. So
restart the system in the sense?
Database bounds. Complete database should be. So that is the reason. Sorry?
My question is, say as a user, by mistake, if he didn't commit and then went off, it means we cannot do anything. We cannot just kill that particular user session or something like that.
You can see you got disconnected, right? That particular user disconnected that particular session. So session is not available.
Okay.
But log is placed on the system, so it becomes an orphan log.
Okay. So, but for that, if we are bringing the system down, it's going to be downtime, right, for the whole application?
Exactly. Not for the application, applications wide. So globally, all the applications that are connected to this, so will be down.
Yeah, connected to that particular server or the database.
Yes. So that is the reason Teradata is a BTET. It's a auto commit. It's not ANSI SQL. ANSI. The transaction. There are two types of transactions. It's auto commit. Whenever you commit the data, you're done with the data, so data will be committed automatically.
Okay.
But even still, we see some transactions that are left over, because explicitly user may connect and he may give change the transaction mode into ANSI, and he may execute the queries and he forgot to do that. Yes. So in such cases it will be there. So that is the reason maybe lock will be placed. Otherwise, even not only that, suppose you are doing you are inserting the data into a table, then you will see a write lock on the table. So that can be seen from log display. So all the kinds of logs that you can see from log display.
Okay.
vproc manager, virtual processors, like I said, if there is a AMP failure, there may be AMP down or reached offline or something. So status of the AMP, if you want to know, if you want to see, then vproc manager is the utility. It's not a troubleshooting thing. It is just displays the status of that vproc. You can change them once everything is cleared, the errors and everything. If it is offline, you can create it, make it as online. But everything is done by vendor itself, because if there is any restart or something happens, Teradata folks will be involved in that. So you can just get the status from this. Query session, the same thing. If that can be done from viewpoint. Sometimes system may be busy because of that. Super busy. It's not busy. It's super busy. So you cannot connect to the system. So viewpoint, it's again, viewpoint is also an application. So it may not get the resources to refresh the data, gather the data. So in such cases, you can connect from backend, and you can see what are the sessions running on the system.
Okay.
So that is query session. DBS control, this is another utility where the parameters, configuration file, you can say all the default values set up. So that can be, you can change if required, otherwise they will be there. So you will find around more than 1,000 parameters. So those are all in DBS control. So that we can see. Check table, as I said, to find the status of the table and to check the table headers and all those. So we run check table. Scan disk to identify any errors or failures or any issues from the disk level, disk arrays, physical disk drives. So for that we need to run scan disk. These are very, it's not very often. When there is an upgrade or maybe hardware failure, disk array failure, so they ask us to run scan disk sometimes. Or maybe if it is a major upgrade, version upgrade, definitely you have to run scan disk and check it. There are different levels that we discuss. So these are all things that we have we cover under DBC, I mean DBA part. So, any questions here that you want to know?
Okay. Okay. One thing is give me a minute. 1 minute.
Okay.
I had some questions.
No, it will be.
I'm just trying to understand what would be the real job for the Teradata DBAs. I mean, the vendor. What is their responsibility and what would be mine?
For Teradata people or Teradata DBAs?
The Teradata DBA. You said most of the stuff, like the core administration stuff, you said Teradata DBAs will be doing, right? I mean, Teradata DBA in the sense I'm talking about the vendor guys.
No, suppose you are into Teradata and you are part of Teradata DBA for that particular, let's say suppose there is a customer and you are supporting that particular customer, then definitely you have to do that. You are not from Teradata Corporation, right? But still you are the DBA in that for that client, so you have to do that.
Okay, because you said some of the activities that you have to contact vendor So they will be taking
Okay.
care of it, right?
Yes, that is like
Like
suppose
I'm
there
just
is a
trying to
database
understand.
bound.
Uh-huh.
Suppose there is a database bounce, restart happened.
Okay.
So there will be a dump generated by automatically there will be a dump generated, crash dumps we call it as. So that will be
Okay.
generated and that will be um, analyzed by Teradata itself, the vendor, not by the
Okay.
DBS, because they
Oh,
need source code to dig into that. So for that they need that.
okay.
Similarly,
Understood.
suppose there is a hardware failure, disk array failure.
Mm-hmm.
So in such cases, we cannot do anything because remotely someone has to connect, or maybe they have to go to the data center and they need to change the drives or failed components. It may be a UPS failure, Ethernet card failures, or maybe some kind of disk array failures, BiNet failures. So these, when such kind of things happen, we don't do anything. We cannot do anything. So
Okay.
they will connect and they will do that because the node control the hardware component, whatever the control that
Mm-hmm.
is controlled by Teradata. They maintain everything. We only look into the logical data, LDM. So tables and whatever the data you have, databases, users. So that is handled by the DBS.
Okay.
Whatever we discuss uh, in this course,
Mm-hmm.
90, I would say 99% only these are the activities that a DBA will do.
Okay.
99%, maybe 1% we may skip, we can something like suppose let's say net backup.
Mm-hmm.
So the front end is ArcMain, that is what you have to do, but the tape, whatever the dump that you have taken, that should be copied onto the net backup, that server. So that is
Okay.
also a DBS work. It's a task should be done by DBA, but since we
Mm-hmm.
don't have net backup handy, so I cannot show you that. So that comes
I
under
understood.
1%. That comes under
Okay.
1%.
Okay.
Except that whatever that we discuss here, 99%, not day to day, every whatever the task you do in a year, so
Mm-hmm.
99% I can cover.
Okay. That's perfect.
Yeah, you can do some hands-on examples also. You can perform on your
Mm-hmm.
system, laptop.
Yeah, that will help me. And one more question. Uh, yeah, so what about does Teradata have its own jobs, bad jobs, or any job which we can schedule it in Teradata?
Yeah, you can define.
Because
You can use cron tab. Most of the
Mhm.
times, most of the customers they go with cron tab, cron jobs. If you want to schedule anything,
Okay.
and if you have any other, some customers they have their own schedulers. You can do from Windows also.
Okay. So is there anything inbuilt with the Teradata itself where you can schedule?
Um, we used to have query scheduler, but nobody is using that.
Okay. We have something like priority scheduler. I mean, I just
No,
read
no.
somewhere.
Priority scheduler is completely different. It's a TASM concept. The
What
scheduler
is that?
that
Uh-huh.
scheduler that we are talking, you are talking priority scheduler and the query scheduler. Both are different concepts. If you suppose
Okay.
you want to, if you have a job that should run every day, maybe a backup job
Okay.
that needs to be run every day midnight.
Mm-hmm.
So you cannot sit and you cannot trigger that particular job, right? So you
Yeah.
can schedule a job. So that comes under scheduling part, job scheduling. So that is what I was telling,
Query
cron
schedule
job. Yeah.
or cron job.
So yes, that you can do. Other thing is that you are talking about priority scheduler. This is TASM. TASM is
What is that?
suppose you want to TASM.
Okay.
Um, So suppose we are two users. I'm a developer, you're a DBA, and you need to perform backups and restore kind of things. And I do my only application related data, whatever the backup I want to do, DML operations. So some hours during off hours, maybe after the business hours, I cannot, I may not, I can run the queries, but I don't get complete system resource. I should not.
Okay.
So during off hours, you will have high priority so that you can do whatever the backups you want to do, you can take the backup. So that there will be less resource consumption from end user perspective. During business hours, if I want to run something and I want to load the data into a table, that should be done on priority, or maybe I need to generate a report. There are some SLAs that I need to meet. So in that case, during business hours, I'll get more resources, CPU resources, CPU or IO.
I understood.
So out of 24 hours, 12 hours are given to the reporting purpose, or maybe for applications, and 12 hours given to the DBS, or maybe 18 hours given to the business users, and 6 hours given to the maintenance activity. So during this time, 6 hours, DBAs or their related tasks will have more resources. During 18 hours or other 18 hours, they will get less resources. So this way you can prioritize the things. So there are different priorities: low priority, medium priority, high, and rush. So based on the account string, the application, everything will be set up. So that is priority scheduler. I'll give you brief, like I'll show you what is rule set, what is workload designer, and how you can define a throttle, filters. If you want, I can give you briefly, give you the details. But you want in-depth, it's not part of this DBA activities, whatever the course that I have shown you. So it's completely advanced. It's advanced in the sense you don't find most of the things you don't find in the market. So if you want, but it's part of DBA's job. Sometimes you need to, if you are into that architect level, then definitely you have to work on that.
So I understand.
If you want, I can give you the details. So that is completely different concept.
Understood. Okay. Yeah, I mean, just introduction or a small brief should be fine, right? At least to start with.
But I can walk through that particular workflow designer so that you will get some idea.
Okay, sure. And so you'll be sharing the PPTs or whatever you are showing to me, right?
Yeah, once we complete with that topic, I'll send you that.
Okay.
Those PPTs.
Okay.